Good morning. Good morning, everyone. I discovered that there's some issues of submission of 12, quiz number 12. I only see one copy. I believe there are more copies were submitted. But when I was trying to grade it, there's only one copy left. I'm asking every one of you to resubmit quiz number 12. Okay, so please resubmit quiz number 12. All right, after class, okay, I'm going to have to set it up, reset it up. For some reason, I don't know what happened. Something was not working right. So I'm going to set the, I'm going to make it available. Okay, hold on. Let's resubmit it. Let's resubmit quiz number 12 until Wednesday. Okay. So please redo it. All right, guys. So please. Okay, guys. I was just talking about quiz number 12, and there's some issues with submission. I only see one copy from my end, so I wasn't able to grade it. So please submit quiz number 12 one more time. I think the system or whatever, or there's something I didn't do right. And I thought I did follow the instructions as how to set up. So please resubmit it. So this new deadline is going to be Wednesday this week, Wednesday midnight. Okay, so I'll be sending everybody a message about this. I just discovered this morning. And over the weekend, of course, I was trying to grade it and it didn't work. There's only one copy, so I was trying to do something, but it didn't go through. So I wasn't able to retrieve those submissions, but I haven't graded them. So please resubmit it after class. Okay, you still have until Wednesday, but do it as soon as possible. Okay. All right. So without further ado, let's look at what are we going to do today. Well, this week is week number 8. This is week number 8. And next week is going to be spring break. Okay. Week number 8, we are going to have midterm exam. Okay, so we have planned for midterm exam. The midterm exam will be given to you at the end of this week, Thursday. Okay. So you will have until the end of spring break to finish. You have the end of spring break to finish. So during the week, we will still continue to cover whatever topics we're going to cover. So the midterm will be available on Thursday, which is 0409, I believe. Let me look at my Let's look at the dates. Is that right? Thursday is the 9th. No, Thursday is the 8th. So through next week is spring break through 04/18/2021. So that's when it's due, okay? The midterm obviously is going to be much longer than the regular quiz or exam, and you will have 3 times to attempt to try it. The highest grade will be it will be in the record. So please do prepare, okay? Because you're gonna have a limited amount of time to do the quiz or to do the midterm exam. And please do prepare well. What will be covered? Okay, what will be covered? Everything we've done from the beginning of the semester until the point that we finish this week. We finish this week. Okay. And today, first, I'll be asking you, oh, hold on, let me write it down. Okay, coverage. Okay, everything from the beginning of the semester till this week. Till week number 8. How about that? Okay, so 1, please resubmit quiz number 12. Number 2, midterm exam is going to be available on the 8th of this week and throughout the end of spring break. Okay, so you have more than a week to do this. So you must do a good job. I'm sure you will do a good job. I expect you to do a great job. Okay, coverage, everything from the beginning of the semester till week number 8. So is that clear, everybody? Okay, do you have any questions on anything? Do you have any questions on whatever, anything we have covered? Anything we have covered? The latest we have covered are, inequalities and quadratic, everything quadratic. Okay. We've covered it in quite a detail. With every aspect. All right. So next, let's see. Do you guys have any questions? No questions? Let me see what's on chat. Anybody has any questions on chat? Are you guys doing homework? Okay, we move forward. Okay, I assume you guys have done your homework and you don't have any questions. Okay, so fast forward. Okay, on basic 11, those are about interval expressions. Okay, basic 11. Okay. You guys looking at basic 11?
Yeah.
Okay. A set of real numbers, say a typical one is x, is highlighted in the graph. Find an absolute value inequality for each graph so that all the numbers in the set are its solutions. Can you express that using absolute value? Using absolute value. We're done absolute value. We solve absolute value equations, inequalities in basic 4, 5, 6-ish, right? So can you write the absolute value inequalities from the picture? Yeah. Can you guys try a few? Okay, we in basic 11 we have A, B, C, D, E, F. Okay, gradually getting harder. Gradually getting harder. Tick mark. Yeah. The first one. How do you express the first one? So let's work on one that's simpler. Hmm?
Absolute value of x is less than or equal to 2.
Can you speak louder?
The absolute value of x is less than or equal to 2.
Good. Very good. Very good. Okay. So there's these two are the points, right? Did everybody get it? How about the second one? We got the first one, right? How about the second one? Huh. These picture cannot graph the one-dimensional. Absolute value of x is less than or equal to 2. Okay. Let's look at the second one. So this is A. How about second one? Let me see some answers in the chat or any form of answers, please.
X is less than or equal to -1, or X is greater than or equal to 1.
Can you write it down on chat? Let's see. Let me make a table to make it easier to organize. The first one, that's A. And the answer was, the absolute value was that. Okay, that's the answer. That's A. B. X less than or equal to -1, or X is larger than or equals to +1. But we want absolute value, so you're almost there. We want absolute value. There's no absolute value in your answer, so you need to have absolute value. Yeah. We want absolute value in the answer. Yeah. Absolute value. ABS. So inequality. There's no absolute value here, even though your answer is right. Okay, your answer is right, but we want absolute value inequality. What would that be? Okay, so let's look at these answers. The second answer, this one, this answer, less than or equal to -1. And this one. Okay, so let me comment on these answers. Okay. absolute value. Absolute value, okay? Thank you for your contribution. One, and the other one is this guy. This is the correct answer, but this one is not. This is a terrible mistake. This is a terrible mistake, which is a common. Just because I'm asking for absolute value, it doesn't mean you should put the absolute value here. Okay, the absolute value of x less than or equal to -1, this one has no solution. This is an empty set. This is an empty set. Okay, the correct answer is this one, is this part alone. So the answer would be just absolute value greater than or equals to 1. You follow me? Just go back to look at what we did in basic 4, 5, 6. You reverse it. It's reversed. Do you guys follow me? This is a reversal of basic 4, 5, 6. Do you see that?
Yeah.
Are you looking at those things? Okay. So let's look at the other contribution. Okay, this is wrong. Hold on. Greater than or equals to 1 with absolute value. Okay, so I'm going to put the comments right next to it so you don't get confused when you take it, okay? So this is the first one. This guy is equivalent to absolute value greater than equals 1, or greater than equals to 1. Okay, they're equivalent. So these questions really just reverse of 4, 5, 6, basic 4, 5, 6. You guys are looking at 4, 5, 6. Look at those exercises. Okay. All right. The second one. This piece. This piece does not make any sense, as it is an empty set. It is an empty set. Okay, no number satisfy that. Okay, this part alone is equivalent to that. You follow me? In basic 4, 5, 6, especially basic 5, 6, revisit basics 4, 5, 6. Please revisit for basic 4, 5, 6. What did we do then? What did we do then? We did something like this, right? Solve for x For example, in basic 4, you're given, say, less than 3. What is the solution? Isn't that reversal of number 1? Number 1 was number 2, right?
Yeah.
So this is reversed. Do you guys see that? Okay. These are examples. Right? What we did then? We also did something like these. Maybe greater than 3. What's the answer? X is less than -3, or X is larger than 3. Isn't that reversal? We did a graph, right? In that process, we did a graph.
Yeah.
Okay, so let's look at the last comments from chat. This, what do you think of this statement? What does this mean? What does this comment mean? What is this? What does it mean? Could you tell me what this means? I'll give you a chance to explain what you mean by writing this. And I will tell you what we will interpret it, how we will interpret it. Okay. Kyle, do you want to take out this opportunity? Vicky, thank you for your contribution. Could you explain to us what you mean by writing that down?
Accidentally, that was a mistake. It was supposed to be absolute value of x greater than or equal to 1, but I was kind of sleepy and I put x.
Oh, okay. Okay, if this is the case, then you're right. Okay, but if you write this, how do we read it? Okay, well, thank you for that contribution. You were right, but you were writing your mind. I cannot go to your mind to visit to see what's actually in your mind. Do you guys follow me? When I see something like this, suppose this is something, okay, then this is not a Kyle then. This is someone else, okay? If someone write this down alone, this is telling the reader the absolute value of any number is going to be greater than or equal to this number. Is that true? The absolute value of any number is going to be greater than that number itself. Is that true? That's how it's being read. You guys, we need to understand what the significance of what we have written down. Do you follow me? You can't just put symbols there and put a couple of symbols and XYZ there without thinking about its meaning, because those, whatever you write down will be judged by your professors. When whoever reads your work according to the grammar of mathematics, according to the grammar of mathematics. In mathematics, we have grammar, we have meaning. So you first have to understand the meaning. You first had to understand the meaning. Then we will be able to judge. Is that right? Or wrong, right? So the meaning is the absolute value of a number is at least the number since you didn't tell me what kind of number this is, Since you didn't specify what x can be, what x cannot be, so this absolute value will be any number. Any number. So I want you guys to judge that statement. Is this statement correct or not?
No, it's wrong.
If it's right, why it's right? If it's wrong, why it is wrong?
It's wrong because the number itself can't be greater than itself.
What? Can you
It's
write it
wrong.
down?
Do you want me to write it in chat?
Please. The statement is wrong. Thank you, Bailey. The statement is wrong because any given number cannot be greater than itself. Well, it can be equal, greater than or equal. So if it were greater, then you'll be close. You'll be close, right? It's greater than or equal. That's a nice try. Very nice try, Bailey. Good job. Think again. Here, I specifically indicate any number. So you may like to think of the number, the sign of the number, right? And think of an absolute value, positive, negative, zero. Positive, negative, zero. Think in that direction. Is this true? Because all we need to judge is that suppose someone put this on the paper, on a piece of paper you turn in. Your reader is obligated, especially your teacher, is obligated to decide to give you points or not giving you points. And how do we decide whether we should give you points, not giving you points, right? If it's right, you get points. If it's wrong, you don't get points. Does that make sense? So now you're standing in the position of a teacher. Okay? So before you turn it in, you better do that before you turn it in. Before you turn it in, you look at your own work and you pretend you're the teacher. You're going to judge every step from left to right, top to bottom before you turn in. That's called a check your work. That's called check your work. Any other contribution? Any other contribution? How do you approach this? How do you approach this? How do you approach this? You know, this weekend I was in my leisure time, I was listening to Elon Musk. He was giving a speech or he was interviewed or something. He said this, you know, which coincided with what I have said. He said, if you don't understand the question, that's the end of solving that problem. You have to understand the question. You have to understand the problem, what the problem is, and properly phrase it. Okay, I'm not quoting him word for word, so just in general meaning. If you don't understand the question, it's usually impossible for you to answer that question. Okay, of course, he was talking about much more larger questions like, you know, humanities, these larger questions. And we're talking about the same thing. If you don't understand the mathematical question, then it's usually impossible for you to answer that correctly. So our focus should be understand the question. Remember, we have always been focusing on the meaning, right? The meaning. If you don't understand the meaning, you may just as well don't take a math class, because you're going to be terribly confused from beginning to end. It's very frustrating. I tell you, it's very frustrating. Okay, don't think I never had that kind of experience. I did too. Okay, everybody should make an effort at least to understand the question. Don't rush to answer it. Don't rush to answer it. Okay. All right, so we understand the meaning. Okay, the meaning of this sentence, you basically telling the reader the absolute value of any number is greater than or equals to x, equal to the number itself, right? Equal to the number. So the number here refer to the number here. Do you follow me? Is my grammar okay? Then you'll be thinking of, is this right with positive number? Is this right with 0? So you basically, the simplest way to judge this, actually, you just say, oh, let me try it. Is it right? Is it right with a positive number? Is it right with 0? Is it right with negative number?
No,
Is it right?
no, because you can't have a negative number in the range.
I'm sorry?
You can't have a negative number in the range, so it's incorrect.
Which one? You're talking about this one?
No, yeah,
Is this statement right or wrong?
it's wrong
Why it's wrong?
because the absolute value of -1 can't be -1.
I didn't say the absolute value of -1 is -1. I'm saying the absolute value of -1 is larger than or equal to -1. Is that still wrong?
I think so.
Is wrong still? The absolute value of -1 indeed is +1. Is a +1 greater than or equals to -1? Is this statement right or wrong?
It's right.
It's right. This symbol means greater than or equal to. It didn't say greater than and equal to. It's greater than or equal to. So this statement is absolutely right. Okay. Now, is it true when it's 0? It's true. Is it true when it's positive? So it's true for positive number, true for 0, it's true for negative. And you can have many, many examples to support this. So is it true or false? Huh? Is it true or false?
Would it be true?
It is true. It is forever true. Okay, I'm going to give you a minute to think about it. The absolute value of a number is at least a number.
That
We
doesn't
need to
follow.
have the ability to judge. based on the mathematical principles. In this case, it is true forever. Right? You can see the original intention that Kai was trying to answer this, question in the graph. He was changing, he was just, he had a typo. But when you have a typo, your statement is meaning completely different things. How is this false, Cortland?
Because I thought the question was asking if you get that same number back.
What do you mean same number back? What does this statement mean?
So I was thinking that the question was asking if you input -1, would you get a -1 for an output? And I was saying that wouldn't be true for -1.
The meaning is the absolute value of -1 is greater than or equal to -1. Greater than or equal to -1. Equal to -1, of course, is not possible, right? But it's or. Remember the truth table we learned? Is greater than -1 is true. So this statement means that the absolute value of -1 is greater than or equal to -1. This is absolutely a true statement. Okay, so now Cortland, can you write down your argument? Wouldn't that be false for the absolute value of a -1? Why is that false?
I had thought that the question was asking if you.
The question, what is the question is asking?
I'm sorry?
Can you write it down what the question is asking in your opinion?
Oh, you want me to write it down?
Please write it down so everybody will follow us, right? When you write it down, you'll be much more careful with the word you use. Okay, take your time. Take your time. I think this will be a meaningful discussion for us. Okay, so all right, thank you. Okay, hold on. I'll be right with you. I'm going to copy your comments. Thank you guys for your contribution. Okay. I thought the question was asking if the output for an absolute value of any number would be at least. Okay. I thought the question was asking if the output for an absolute value okay, so I'm going to copy and paste this comment here. Okay. I'm going to put it right here. By the way, thank you very much. Okay, I really enjoy these discussions. I hope everybody participate. Okay, I thought the question was asking if the output of an absolute value of any number would be at least the input. What do you think of this comment? The output for absolute value is of any number at least input. This comment he put here is absolutely good. Okay, because this is the output of absolute value. Okay, this comment you make here is very good, Cortland. So if your input is -1, you would at least get a -1 as an output. Yeah. So this statement is confirming your statement. So what's wrong with that? Do you think that's right or wrong?
I thought that was wrong at first.
You thought that was wrong. Now you think again, is it true? Is it right or wrong?
I guess it's right.
It's right. Your comment is also right. Your perspective of looking at this as a function, right? Because this one is basically, this is very good. I'm very glad this comes from you. Okay, you have an input, right? And you go through this absolute value and the output. So right now we're talking about just the left-hand side. Oh, sorry. This is the left-hand side. Okay. The left-hand side, for any number it comes out, absolute value of x is going to be at least the input. Okay. This, okay, if your input is -1, you will get at least -1 as output. At least. The key word here is at least. At least means that number or larger, right? So at least means greater than or equal to, yes? If greater than is true, greater than definitely is true, right? The absolute value of -1 is +1. +1 is greater than -1. And in this case, it's the equal to -1, that's a false. We have learned that truth table, didn't we? True or false is what? True or false is what?
It would be true because it's an.
It's
or.
true. True or false is true. Do you see these logical relationship? I think that was a very good discussion. I think it's a very good discussion. In fact, Kyle typed this accidentally. He probably didn't realize it was a true statement, didn't you, Kyle?
I didn't.
It wasn't the answer, right? Kyle, are you there?
Yeah, I'm here.
But you accidentally typed a true statement. Did you realize that then?
A little bit. I kind of understood that because you could input any number inside X and it would be true on the other side.
No. You need to understand it in its full meaning.
Yeah.
Don't think of inside, outside. You need to think of its true meaning. That's why we have so much difficulties. A lot of our students have so much difficulties because they got carried away by those symbols and they don't fully understand the symbols. Those symbols are just shorthand words in shorthand. You have to understand the full meaning. To tell you the truth, if I didn't understand the true meaning of all these symbols, I cannot possibly teach this class. And I will be totally lost. I'll be sounding like I'm talking to myself because I didn't know what I'm talking about. Have you guys talked to someone that you said they sounded like they don't know what they're talking about? If you haven't, you're lucky. Okay. Had I changed this, and Bailey later earlier comment on this sentence, which is also a very good one. Okay. Of course, he said that statement is false, right? He said this statement is false, but he gave a very interesting meaning. The statement is wrong because a given number cannot be greater than itself. He said, any given number cannot be greater than self. Any greater number cannot be greater than itself. That is true. Okay? You cannot say X is greater than X. But this statement is different. Okay, this statement is different. You said any given number cannot be larger than itself, greater than itself. You mean this one? Do you follow me? But it's a good thing is you're trying to make a connection between the statement in mathematical form and the statement in the words. When you practice more of these, you'll be better at this. Do you follow me? This doesn't mean that. It doesn't mean that the number is, any given number. This any given number is taken absolute value. It's being taken absolute value. This will be false. You see, just a little bit change. This will be false. And this will be true. Do you follow me? Yeah? Does everybody follow me? What does this mean? What does that mean? I already give you the answer. Can you figure out the reason? This is true. We already discussed. Why this is false? You see, the difference is minimal, right? The difference is minimal, right? But that little difference makes a big difference. That's how mathematics, how rigorous mathematics has to be. Every little difference is a difference. So why is this false? You can give a counterexample, right? You can give a counterexample. The absolute value of 0 is the same as 0. Larger than 0, this is false. Counterexample. Hold on. Right? This is false. This is not true. 0 larger than 0 is false, right? This one will be fitting that 0 cannot be greater than 0. Do you follow me? I'm going to copy your sentence. Zero cannot be greater than 0. Okay, guys, do you guys follow me? These are the effort to understand the mathematics, what it means. And we gain ability to make, to judge. Okay, so let's see, there are 2 messages in this. Okay, Kyle said, any given number cannot be greater than itself when absolute value of X is positive but false when negative. Any number cannot be greater than itself when absolute value of X is positive. When absolute value of X is positive, that's a false statement. Absolute value of X is positive, that's a false statement. You guys keep making that statement. The absolute value of a number is not a positive always because the existence of 0. The absolute value of any number is always non-negative. Okay, Kyle, I don't know what you meant.
I mean, like if you have like an absolute value of +1 is less than or equal to 1, that's only true because it's the equals, because it says greater than or equal to 1. So we would use the equal to.
But when
But
you
then-
put these two together, what does that mean? Can you I don't understand. Can you explain to the class and also to me? Okay, I put it on the screen. Everybody, I think every one of us need to practice this language. Any given number cannot be greater than itself. That's true. Okay, we just discussed that. When absolute value of x is positive, that's false. But false when negative, then what does that mean?
I guess I didn't write the whole thing in the chat, but I guess what I meant was like the absolute, like the value of x when the x is a positive number, like then any number.
Okay, then write
And it's
it down. Then
like,
please
do I
write
give
it
an
down.
example or okay, I'll
Okay, because I cannot understand you. If I cannot understand you, I cannot give you the answer for you are right or wrong. Okay. Okay, so now I'm telling you this statement, any given number cannot be greater than itself. That's correct. Does everybody follow me? What I'm trying to show you, I need to be very, very careful as a teacher standing on my podium to give you information. If I don't have a complete information or if I don't understand your information, I cannot tell you because I don't have any opinion. Because if I don't understand, I will tell you I don't understand. I will not tell you it's true or false. Okay, this is true. We already tell you. Okay, and then you say you put the words when. Okay, I don't know what that word is meaning, and then you go ahead and you say at the absolute value of x. Okay, you say absolute value of x is positive. So because you didn't specify x, what is x? So I would assume x can be any real number. And I'm telling you, this is a false statement. This is a very, very common mistake. Very, very common. Common mistake. I would say 99% of the students would tell me the absolute value of a number is positive. It's completely wrong. It's a wrong statement. How do you make it right? The absolute value of x is positive or 0. This is one way to make it right. Okay. Another way to make it right is non-negative. So what I have demonstrated to you, this is how we work with the words, even though we're doing mathematics. A lot of time we're doing the mathematical expression, but you really have to understand it's a concise meaning in words. If you mixed up, and your statement will be judged very, very, I would say your statement will be judged very objectively by the grammar of mathematics. Okay. So now, thank you for your comments. So let's look at the next one. The absolute value of x of a negative number is greater than its negative counterpart. The absolute value, I really appreciate you guys making all these efforts trying to make it right. Is that right? Oh, I'm copying this again. Okay. And the next statement you're saying the absolute value of x, you mean this x is negative, right? Is that what you meant?
Yeah.
It's
Yes.
greater than its negative counterpart. What is the negative counterpart? What do you mean by negative counterpart?
I just mean like if absolute value of -1 equals 1, then the input of like
Okay. You're giving the example of absolute value of -1.
so it's like if
equals
absolute
So
value.
who is the counterpart? Tell me.
Okay, I just meant like if we look at the like absolute value of x less than or absolute value of x greater than or equal to x, then we would just have x equal to -1. Like,
Okay, the absolute value of x greater than or equal to x. You have
and then
x,
x,
-1.
yeah.
Yes.
Yeah,
So what do you mean? What do you mean greater than is, what is the negative counterpart? I don't, what is the counterpart?
I just meant that like what you would input as x would be the same as the output, but
The input as x will be the same as the
Wait.
output. The input to what? To what function?
and then I was imagining like that.
Hmm?
Where is my dad?
The absolute value of x is equal to itself when positive. Yes, got it. Absolute value of x greater than equals to x when x equals to -1. When
Yeah, and
x
then
equals to -1, it will be greater than, right?
yeah,
Is that what you mean? But where do you get the word of counterpart? I don't understand what is a counterpart.
I just put it to mean like the input, like the values
Okay, just
of
tell
the,
me in this example, which one is the counterpart of what?
it's -1. It's on the it's -1 on the it's -1. It's not
So
not
that is
absolute value -1, like just -1. -1
-1 is the counterpart of what?
of
Okay, how about
Okay.
you? When you come up with the answer, you come to my office, okay?
Okay.
Don't use these words. These words have no definition in mathematics. If I don't understand, if the reader doesn't understand, and you will only confuse people. Here you have confused me because I don't understand what you mean anymore. Do you follow me? Do you guys follow me? You don't say anything that's not a well defined. I think after we study mathematics, we will become more careful about what we say. I think that's one of the benefit I get of myself personally. Every word I utter, I think about, what do I mean? Did I really mean that? Okay. I hope everybody benefited from this discussion. What we come away with is that whenever you say something, when you write it down something in mathematics, they have significant meanings. And you will be judged accordingly. You'll be judged accordingly. And the big takeaway for myself is, I think after I study mathematics for, after, all these college studies and stuff, I'm a more logical person. Okay, well, I'm a more logical. Okay, I'm also more careful about what I say. And I'm also very careful about, for example, if I make any statement, I will have to think about it over and over again. For example, in the department meetings or in, even in my social life, I'm being very, very careful about what I say. I don't say random things, which is may be true or may not be true. If I don't know, I just tell people I don't know. Okay, I think I would be more true to myself. I wouldn't be like, saying things, feeling obligated. I have to say something. Well, I don't have to say something. I don't say something. Okay. And you use words very, very carefully. You use words very, very carefully, whether it's your native language or your non-native language. English is not my mother tongue, but I need to be extremely careful about the words I say. Okay, anyway, without further ado, let's go back to 11. Okay, so we accidentally discover something that is always true, isn't it? Thanks to Kyle. Thanks to Kyle. Very interesting, very good discussions. I would like to continue with that discussion with you in my office hours. You will come. And I think this process train us. This process is training us. It's training us to be more mindful of the words we're saying, the words we utter. So we can say words more responsibly. Okay, and mindfully. But anyway, without further ado, I think you guys should be able to do everything in basic 11. Basic 12, that was just a review of a function concept. We're not going to spend more time. Basic 14, basic 13, 14. And I think that we're going to move forward. We're going to move forward. Hold on a second. Basic 13. Maybe we should just wait, just spend a little bit of time on basic 14. By the way, as we're going to move on to basic 13, I'm going to re-emphasize to you guys again, please resubmit quiz number 12. Okay, for some technical issues, your quizzes are not there anymore if you have submitted earlier. I have only one copy of the quiz from one of you. That doesn't seem right. Okay, so please submit one more time. Okay, as soon as possible, as soon as possible. I was trying to grade it over the weekend. I wasn't able to grade it. All right, so let's look at basic 13. Some basic logics is being used here. Okay, some basic logic is used here. Basic 14. Okay. First of all, recall truth table. Do you guys still remember truth tables? Do we still remember truth tables on second page of notes? Yeah?
Yeah.
We went over truth table, didn't we?
Yeah.
So from that truth table, what have we learned? And or are different, right? When we make a composite statement, statement A, statement B, statement A, statement B. Okay, and more statement A and B, A or B. These statements, okay? If we make a table of these statements, right? A is a statement. B is a statement. A and B is a statement. When you put these together, okay, A or B, statement, one statement, one statement, one statement, one statement. These are four different statements. Four different statements. You're making, when you put two statements together, it will be judged as and. If it's the and, it will be judged a certain way. We had this discussion about, you know, the statement we make for car seat and so on and so forth, right? There are a lot of similar situations. In the logical aspect of mathematics, it is actually the same as in the legal system, in law. And or these words are used in the same way in mathematics as they are used in law, in legal system. Okay, so what we have discussed is that, you know, for A, it could be true, it could be false. Both are could be true, it could be false. Okay, it could be true, false, could be false or true. These are different combinations. Of course, for A or B, it's either true or false. It's either true or false. But when we do A and B is only true when both are true. I remember I gave you a quiz about this, right? Yes, I did I give you a quiz about this? Yes. A or B is true if both are true. If both are false, A and B is false. If both are false, A or B is false. However, the interesting come here. If A is true, B is false, A and B is false. If A is true, B is false, A or B will be true. Do you guys see that? Big difference. If A is false, B is true, A and B is false. If A is true, B is false, A or B is true. Okay, these truth tables seem to be very simple. This truth table, I'm making a statement. Okay, this truth table is the foundation of computer science. This truth table is the basics of computer science. The only difference they use here they use binary code. They use binary code. Instead of using true, they use 1, 1. Okay, true is 1, false is 0. So 1, 1, 0. This is a binary operation. We know binary operation is essential for computer science, right? You follow me? This is a foundation of computer science. The difference is, what's the difference? The difference is true is 1, false is 0. Okay, this is the foundation of computer science. I couldn't emphasize this enough. I couldn't emphasize that statement enough. A build on this. Computer science is built on this bit by bit. Okay, you know, computer science has developed into what, right? It changed our time. It changed the way people live, right? Amazon, Google. What is the very foundation? The very foundation is here, right in front of you. Very simple, isn't it? Very simple, isn't it? And you build on this, you build on a gigantic system, very rigorously. No gray area allowed. If there's a gray area, your computer will crash. Okay, computer will crash. Okay. So now let's look at some of the building blocks. Okay, examples. Basic 13. In basic 13, we introduced some other logical operations. Okay, so here we are talking about A is a set. Okay, A is a set. Okay, so let me make a statement. A, B are sets. Do you guys understand what is a set? What is a set? Set is just basically a collection of numbers in this case. Okay, so A has 1, 2, 3, 4. Okay, B is also a set. Okay, 3, 4, 5. Have you guys learned about or heard about Venn diagram? Okay, if you haven't heard about it, then we're going to talk about it later. Okay, so we're going to go straight to the definition. We're going to go straight to definition. What is A or B? A union B, A or B, right? So I'm going to put the definition O here. A could be a statement, B could be a statement. So A or B, A could be sets. Okay, so in A, you have a bunch of stuff, and in B, you have a bunch of stuff. I think we use A, B in the definition of function, right? So now, A or B, okay, so this is read as A or B, or A union B. Okay, so A or B. Okay, or A union B. A or B or A union B. Do you guys follow me? I want to get the grammar right to you. Does everybody follow me? Okay. How is A union B defined? Right, A is a set, B is a set. Okay, A, B are sets. Sets of numbers, or it could be sets of letters or sets of different categories, right? It's a fairly abstract concept, but we're gonna use some simple examples to operate on these. For example, A or B, meaning that this is a new set. This new set is composed of elements and specified, okay, so X followed by a bar. And after bar is the specifics about X. About X. Okay, so after you can see the structure of this mathematical notation, right? So A or B is a set. This set is made of numbers or elements. And behind the bar, we explain what are the specifics about X. In this case, we will say A is, X is in A, or X is in B. What is or? This is a table about or. We use this table or to judge. Do you follow me? Okay. So now I'm going to make these, I'm going to make a table again. Okay, just make it, I think this is easier. A or B or A union B. So this will make it easier for you to take notes. The font change of this software is sometimes it's a little awkward. Okay, I have to do it, but I want to do it right for you. Okay, so A or B is defined as, A union B is defined as every element is in A or in B. Okay, and the other definition will be A and B. Okay, and the other way to say it is this notation. A and B. Okay, the U upside down. Okay, that's A and B. How is it being defined? Okay, I'm gonna borrow this and the or turn into and. Did you write it down? Did you guys write it down?
Yeah.
And this process is training us to use the truth table. Truth table, A and B, A or B, okay? The next definition is A minus B. A minus B, okay? What does it mean? A minus B will contain elements X such that, okay, specifics, okay, X is in A and X is not in B. Not in B. Lots of mathematical notation, lots of shorthand notation. Does everybody follow me? This little notation here Okay, let me illustrate. This little notation, this symbol, meaning belongs to. Okay, this other notation belongs to, okay? And not belongs to, not belong to. Not belong to. Does everybody follow me? Okay. Belongs to or in. Okay. Not belongs to mean not in. Is that clear, everybody? Is there anything that you don't understand? Please ask. Because all of these are shorthand notations. Lots of shorthand notations. So these are the three major definitions that we're learning here. With basic 13, we're going to apply these three definitions. We're going to apply these definitions. Okay, so here you're going to learn about, for this is specific A, B, and how we make A union B. I'm going to describe you the process, okay? So be patient with me. Be patient with me. A, okay, so you go through every element in A or B, in A and B. And then you're going to judge them whether they should belong to A union B by the definition. For example, 1 is in A. If any number make this statement true, that number should be in A or B. Do you follow me? If any number make that statement true, that number should be in A or B. Do you follow me? Okay, so 1 make that statement true because 1 is in A, right? If this statement is true, then this statement or any other statement is true because A or B is true if one of them is true. Yeah? Yes, do you follow me? So 1 is in it, 2 is in A, therefore this statement is true. 3 is in it, and this statement is true. 3, 4, 5. So 1, 2, 3, 4, 5. That's how you do this. You do it by definition. You follow me? A and B. Okay, A and B. A and B, any element in A and B, I'm sorry, this would be the other way, sorry. Okay, A and B is true. Well, any element that in A and B, it must make this statement true. But this is an and statement. In and statement, both statements must be true for the, for the and statement to be true. Therefore, you look at 1, why, right? 1 is in A, that's true, but 1 is not in B. Therefore, 1 does not make this statement true. Therefore, 1 is not in A and B. Now, look at 2. 2 is in A, but 2 is not in B. So X2 belongs to A is true, and 2 belongs to B is false. True and false is false. Do you follow me? So 2 is not in. 3 is in A and 3 is in B. So 3 in A and 3 in B are true. They're true and true is true because two statements, one statement and another statement is true. only when both are true. So 3 is in there. Do you follow me, guys? So this is how you do it. This is the kind of training I highly recommend it to you, okay? 4, same way. 4 is in A and in B, therefore 4 is in A and B. 5 is not in A, but in B. So 5 in A is false and 5 in B is true. False and true is false. Therefore, 5 is not in A and B. Do you follow me?
Yes.
Okay, so all these logical thoughts. Now let's look at A minus B. A minus B. We're basically simulating a machine, you can say an AI machine in this process. Okay, so A minus B. A minus B basically say this must be true and this must be true. Only when this statement is true, that element is in A minus B. Do you guys follow me? So this is a little bit more complicated. Okay, so let's go. A is in, I'm sorry, 1 is in A and 1 is not in B is true. So true and true is true. Therefore, 1 is in A minus B. 2 is in A, that's true, and 2 is not in B is also true. Therefore, 2 is in B in A minus B. 3 is in A, but 3 is not in B is false. So true and false is false. 4 is in A and 4 is not in B is false. So true and false is false. 5 is not in A, so that's a false, and anything is false. That's pretty exhausting for me to say that. Did I make any mistake? I hope not.
No, it was all correct.
This is how you read it. This is how you follow that, okay? Of course, we're doing a simple, fairly simple example. So you figure out very quickly how to work it. But the real training is really behind how you work with the truth table. Do you guys follow me? How you work with the truth table. All right? So this is how you do basic 13. Basic 14, please do it, okay? This is just how to make, how to write intervals. You guys should be good at it. Number 15 is about how to specify the range, right, vertically. And basic 16 is similar to 13. Basic 16 is similar to 13, except it's working with interval. You apply the same definition. Okay? So you guys have some work to do. Basic 17, apply the definition of function, vertical line test, horizontal, vertical line test, just a vertical line test, okay? Basic 18, I don't plan to spend time here. Basic 18, you will be using it. You actually will be using it in calculus 1, just about finding line equations. So please do them to see if you know how to do them. If you have any questions, then please feel free to ask me. We don't do B minus A. B minus A is the same idea as A minus B. It's just in in B, not in A. Did you get it, Mikhail? B minus A, just a switch place, the same definition. Okay? All right, so if you have any questions, please don't hesitate. Tomorrow, we will be doing basic 19A. So your homework today is 18A from basic 12 No, basic 11. Through basics 18. We went very fast in this section. I kind of assume you guys, most of you guys are okay with this. Okay, but if you have any questions, please don't hesitate to ask me. And tomorrow we will be doing basic 19A. Do you follow me? So today we did a lot of logic stuff, words, how to decide, how to use the words, okay? The common mistakes, right? Like people say the absolute value of a number is always a positive. It's wrong. It's a wrong statement. Why I always hear about it? It's a wrong statement, right? Speak very carefully. Speak very carefully. Okay. Because once the words is out, it's like a spilled milk, right? It's like a spilled milk. You can't get them back. Can't get them back. Be very careful about what we say. Okay. Especially when you take a math class. I enjoy the discussion with you. If you guys want to discuss with me some more, welcome to my office hours. And otherwise, and I'm heading to my office hours. I'll see you guys tomorrow. And so please, once again, submit your quiz number 12 once more. Okay. See you guys tomorrow. Very good participation. Okay, I couldn't thank you enough for the great contribution. Really, really helpful for my lecture. I hope I have helped you in that way.